Okay, college algebra, it's your turn. And unfortunately, we're starting with what is arguably the hardest section of college algebra, not the longest like the homework was for the previous ones. This is probably the hardest one to learn. Ironically, now this is what we get to use as a guinea pig. Okay, so rational functions. Rational functions are functions that are division by x. So something like x plus 3 over x minus 5. Because there's division involved with a rational function, there's all sorts of strange things going on. There's some examples in the first 2 pages of the notes if you just pop them up. What they look like. The reason that they look strange is dividing by 0 causes you to have to jump over certain parts of the domain. Like for here, I couldn't plug 5 in because it would cause me to divide by 0. This creates what we call a vertical asymptote. Now, asymptotes are really guidelines. Now, guidelines to help you graph, because if you notice any of the graphs on the notes, they don't actually have the dotted lines we're talking about, the asymptotes, but we'll use them to graph for our purposes. Now, the other thing that can happen is the end behavior. We have talked about it in previous chapters, which is you go to negative infinity or positive infinity for x. So that's either far to the left or right on the graph. Something that happens in rational functions is everything but the largest term tends to just kind of fall away for the numerator and the denominator, and that creates other things that are happening. So what are the features of rational functions? First, we've got the asymptote. The ones caused by dividing by 0 are vertical asymptotes. And you find them by setting the denominator equal to 0 and solving for x. They are always x equals something lines. Now there's another kind of asymptotes. There can be as many vertical asymptotes as you want in the problem. It really just depends how many factors are in the denominator. There's also either a horizontal or slant or neither. And this is caused by the end behavior. And what that means is as x gets really big or really small. So up here, when the powers of x are even, that creates a horizontal asymptote. There's 3 situations here. When the denominator is bigger than the numerator, so the denominator is, if the denominator overpowers the numerator, then you have an automatic horizontal slant asymptote at y equals 0. If they're equal, you have y equals something where that is a number. How do you find the number? For example, for 3x squared over 5x squared, notice the powers of x's are equal. You just take the ratio of the coefficients, and that's where your horizontal asymptote is. Now, if the denominator is less than the numerator, you have either a slant asymptote or you have none. None of these asymptotes. There's technically a quadratic asymptote, but we're not going to worry about that. If it's exactly 1 bigger, you have a slant asymptote. Now, if you have a slant asymptote, that just means that your dotted line, instead of being horizontal, is going to have like a slope. Like, y equals 5x, up 5 over 1. That's how you'll graph the dotted line. Now again, asymptotes are always graphed as dotted lines. Because they're not part of the graph. So remember, your asymptotes will always be graphed as a dotted line. They are guidelines, they're not part of the graph. Now, these are not the only features you could have. Technically, there's one other feature, and for that we have to talk about, we know what undefined is, right? it's when you divide by 0. Something like 3 divided by 0 is undefined because it's either hugely positive or hugely negative. But what happens when you divide 0 by 0? This is called indeterminate form. Because we don't know what 0 divided by 0 is. So there's no way for us to know. Now, in an irrational function, if we have something like x plus 3 times x plus 1 divided by x plus 3, in your brains you want to say, well, I can just cancel that out and get y equals x plus 1. But there's one exception here. Y is not equal to x plus 1 when x is negative 3. Because then I would have 0 divided by 0, whereas when I plug in over here, I get negative 3 plus 1 would be negative 2. So this, when you have 0 divided by 0, so if you have a shared factor, it creates what we call a hole. And a hole is just going to be an open circle on the graph. You don't know what's happening at that point, and you're just going to put an open circle and kind of jump over it and keep going. And this is the explanation of the features. We'll get to how you actually find them in problems in the next video. I just wanted to talk about those first 2 pages and the features that happen. A hole will create a domain restriction, but you have to be careful and reduce before, because if you just looked at this in the denominator, you might think it's an asymptote, but really, if it's in the numerator as well, it's a hole. So again, we'll see how these all work together in problems in the next video, but I just wanted to give an introduction for now. And the next one will be coming soon.